Hello everyone, my name is Philip and I will be your host for today's session. This is an interview for Rust.careers, the stable Rust job board. If you're looking for a new Rust gig or are currently looking to hire Rust developers, there's no better place than Rust.careers. Today we have an interesting interview ahead of us with Radu. Welcome Radu, how are you doing today and how did you get
Hi,
into
and
Rust?
hi everybody. Thank you and very good thoughts about me. So I'm recently a passionate Rust developers and cryptography enthusiast, and I have a background more than 20 years, mostly in Java, but I experience also C++, and related to this, I was actually a nice thing about my background is I worked at a company called Danger. This was in 2007. It was a US based company and they built their operating system. And they have applications built. The operating system was built in C by some. There was an operating system back then called BEOS. It was multimedia oriented and it didn't caught up. And the team then migrated, and most of the team migrated to this Danger company and built the operating system. And they have the applications written in Java, so they implemented their own JVM with the garbage collector and so on. And actually, there was a brilliant. I think it's less said. I think it's a genius guy there, a South Korean guy who actually built the wrote by himself the garbage collector, and it was written mostly in C and with
Oh wow, so they built Java runtime
yeah,
by
yeah, Java
themselves
runtime.
pretty
And this
much.
guy alone built the garbage collector, which okay is the basics of the Java runtime, and he was actually brilliant. So it was very. I remember a status call when he came and just realized there was a very professional and very uh, people with a lot of experience there. So there were people from BEOS, like I said, operating system company. There were people from I think Panasonic who works on the radio stuff. There were people with networking experience. So there are people that wrote the TCP/IP implementation. So they are very good people. And we get around at the table and we all said, okay, what have I worked on this week or something? And when the table got to him, and he said, I work on optimizing some memory management on the garbage collector, and it is a bit difficult to explain to a normal mind. Normal mind being a lot of
Yeah.
other brilliant people. So he was very bright, and I was very honored to work in that team. I was actually it is actually my let's say favorite project that I've been involved in. Nice story is that it was co-founded by a guy called Andy Rubin. Maybe some of you know Andy Rubin, and Andy Rubin left, and he founded another phone company with an operating system, and that company was bought by Google, and Google bring on 10,000 more people, and this is how Android was born. So actually was working for the grandfather of Android. So this is a it,
Wow, that's really
yeah,
cool. It's pre-Android
yeah, it
days.
was very nice because when I was after this project somehow died because long story short, Microsoft bought it and they buried it, unfortunately. And so actually they did like because it was a bit of a scandal back then. They did like back they did like a upgrade of the Oracle database in the cloud, and they wanted to reduce the cost, so they didn't have uh, any backup, so they didn't back up the DB before doing the upgrade, and it was a software upgrade for the for the Oracle, and the change log in the Oracle uh, release was saying that optimizing the space usage of the databases, and they did such a great optimization that they deleted all the data. So
They just wiped everything out.
yeah, they wiped everything out. So all the tables were empty, and
Shit.
it was like so. This was the cloud, and they had like devices, and the idea was that the cloud was always considered like the source of trust and the source of truth. And when the devices were having some issues, also the support guys were instructed to tell them that. reset from the cloud, and they delete the local data and reset from the cloud. When they did this reset, actually they deleted everything on their machine because they was interpreted like everything was deleted, and actually they deleted the data also from the devices. And then we had like epopeia, so like a journey to somehow create application to force the devices to push the contacts and the information back to the server. So we had to do hacks like, okay, the advantage was that we have access to the source code, but we have to do hacks like faking the IDs and the less modified date to put like dates in the future and IDs greater, so that you can consider that the device data is in newer and to force it to push on the server.
So they were like faking the
Yeah, yeah.
timestamp,
This is a hack
basically.
that we found to force the device to push the data and not to interpret. So somehow to interpret the server changes as old changes, because when there was a like you don't have internet connection, you make changes on both ends, and then when you sync, you have a conflict. And then which version do you keep? And we forced to keep the device version. And after like 1 month, then the Hitachi engineer came and they had like they managed to do a hardware recovery, so they recovered the data from the hard disk. But the problem was that given the space was limited, the new data that we pushed overwritten some data that were there, and they couldn't recover all the data. They recovered some, and the guy who was responsible of the project said, I realize now that if we have never do anything all this month, it would have been better because we will have recovered all the data. But now we lost like
Yeah.
30% of it or 50%, and there was like memes there. So this was, just imagine, this was in the company was founded in 2003, and this problem was in 2000, I think 8 or 9, something like that, 2009 maybe. And the cloud, let's say, concept was not so well established. There wasn't so many cloud present back then, but there was some. And the idea was that in the contract, so the company is called Danger, and in the contract there was a phrase like they were saying, okay, uh, your data is now in the danger clusters infrastructure, blah blah, and they extract
It's in the
your
danger
data
zone.
is in danger. They extract your data is in danger. So they made memes like that. It was a big scandal. But just to imagine how, so everybody was very very passionate. This is what I like. Everyone was very passionate. They had very great knowledge and very good experience. So they were all using the phones for their personal use. They were all doing like creating for this product for the best. And the idea is that they they had, so just imagine this, they had in 2003 they had like email client, MSN, AOL, and Yahoo were popular back then. They had a browser, they had a uh, they had a store, application store. If you build application in Java, you have a store. They had a SSH client application. They have a FTP, they have
Okay.
Telnet, they had like uh,
Telnet.
a lot of games, a lot of stuff, and they had like an interesting stuff. So it was something similar like BlackBerry was. So all the traffic was going through their gateway, so like proxy, and the real connection was made from the proxy to the outside world. And for example, this was useful also for the browser because you maybe you remember there the display was not so great. You didn't have so much resolution, and the hardware was also less. And because now you have like monsters in your pocket, and the idea was that they fetched the page from the website, they reduced it to a more smaller content, and this is what they served the browser on the client. So it was a better user experience. And another advantage was very nice. For example, if you create a socket, so let's say you have a chat application, if you or no, if you create a socket and upload the file to the server, the socket was created between the phone and this proxy. Then proxy communicates then with the creates another socket with the real world. And if you go into a tunnel or something, you lose signal. You lose signal with the server. You in your application you could keep writing, and you didn't notice that the signal was lost. It keeps in the buffer, and when the connection is reestablished, they send the packages and they carry on and send to the real destination. So actually you have like a buffer of internet connection, network connectivity, that it can go up and down or off and on, and you didn't even notice. So very very.
That's cool. From a user
Yeah,
perspective,
user and
that's
developer,
really
you
cool.
know, it was, you don't need to handle all these connection down, retry, reconnect again, keep in the buffer. They do this all this. So yeah, it was very nice. So actually, I think that is the greatest, the most beautiful project that I've been part of. And another one was, um, we are doing we were working on it's called EFA Check. It's a Portuguese company. It's like the governmental electrical company, so the country official electrical company, and we were like contractors for them. And what they were doing, so they had like schemas for all the electrical terminals, like I don't know, transformer or all stuff in the town. Sorry, all the wires and everything, and they had like all this in the all these schemas they had in AutoCAD, and they uh, had the schemas, and then they wanted to digitalize it and move it to a software, and they take the schema and manually look and create all this connection in their application, and it took like 2 weeks in average per schema. And what we did, we took this and we imported the AutoCAD schema. We designed like a minimalistic editor application for the schema. Normally, you don't need to edit a lot, but okay, if you want to edit, you can do, because you do it in AutoCAD. If you edit, you edit, and then we use like a primitive neural network. It was a library. It was called leaf detection. It was actually
Hmm.
detecting the contour in a picture, and it was telling you what kind of tree the leaf is from. And we used that. The problem was that when they draw the, let's say, a transformer, they weren't consistent, so there were different teams. So for example, the ideal way will be to draw it once, group it, copy it, and transmit it all over the place. So then we could actually build like an empiric rule, like I don't know, a triangle with a circle inside with a cross, it's a transformer. But we couldn't do this because it was so different that also the number of shapes were different and the type of shapes were different. So everything was like crazy. And of course, we need it. You cannot apply classical algorithms for that. You need neural networks, because this is what it will do. And it actually, after we trained this and after we customized the inputs and so on, the parameters, it was performing quite nice. And actually, we did this. And first, there was a challenge, like how do you even start, and how do you even, I don't know, do this recognition. And how we do it, we randomly took a line, which is a connection between two of them, and we actually walk the line. There is also from Johnny Cash a song, "Walk the Line," and actually walk the line. And
Yeah.
the class, this was written in Java. And we try to find the path to the nearest shape, and then try to recognize the shape, and then move the path to the next shape. And actually, the class was called Pathfinder. the the
Ah.
idea was that we go with the line to the other end. At the other end, we take the shape like a circle, a rectangle, and so on, and we have a boundary, and we keep increase the boundary, and we apply the recognition to this neural network. And when we find the shape, then okay, we consider it's a match. But then it could be a subset of a bigger shape. We keep increasing the boundary until we don't find the shape anymore. So we consider all these to be part of the shape. We mark this as visited, and then we continue like that. And then we build like a model with all this connection. And in order for me to debug this, I was leading this part. And in order for me to debug this, I constructed like another screen where I draw the lines where I move, and then draw the lines where I recognize. So in order for me to have visual recognition of what is happening to debug, and of course I do this with a delay or something like that. And the idea was that I could see everything, and in the end I have the schematics, and this was actually a very useful screen that they consider that keep it, because after you do this all recognition, maybe it's not perfect, so then we can go and change inside these recognized shapes, and don't need to focus on the lines and square and so on, but we only need to focus on these recognized shapes and so on. So the idea is that how the flow works is you have a legend of at each schema, and you go in the legend and you select some shapes, and you say this is a transformer, this is something else, and then based on this I apply the recognition to everything. So this reduce the recognition time from 2 weeks to 1 day to max,
Oh
to max.
wow, that's huge
Yeah,
improvement.
and of course it was not perfect, but in this full day they managed to recognize and fix all because they're looking visually over the shapes, and in one day they were very happy with this with this product. It was very interesting. And just to finish with my background, so at some point I had some personal issues, and I took like a time off, like sabbatical year, let's call it. And I
Yeah.
didn't program at all in that year, so I used laptop only for news and movies, let's say, and documentaries. And looking back, I cannot believe I actually managed to do this, because I'm a very passionate programmer. And I don't know. Okay, I needed that time off, and I saw that I don't know. I don't see a future in continue programming in Java. I was from a developer to technical lead to architect and chief architect. So I'm a man with multiple hats, let's say. And but I always loved programming. I had a lot of offers from the where I was worked to move in the management team, but I never really liked that. Maximum I can do is like like an architect, but I need to be like an architect who develops the POC. So I need to be involved in the coding. I cannot just limit myself at UML and stuff like that. I need more. And
Yeah.
then after that period, I was feeling a need to program again, need to code, and I was introduced by a friend of mine in the Rust about Rust. He was actually he has audio editing application, and he found. So initially he started with a built sound engine that he modified a lot, and then this was in C, and then he realized that it's very hard to maintain and very hard to add new features, and he decided to move into something else. And in the audio space, is very the latency is very important, so you need to focus on having the low latency. Actually, in the first years of his application, the audio in the Android was not so low latency focused, and he was actually having worse performance, quite very considerably worse than on iPad or iOS.
iOS, yeah.
iOS is really great for multimedia, and he he said, okay, I need to move to something else. I cannot move to Java because I don't have the latency. There was I know Go, there was solutions, and somehow he found the Rust, and when he read the main let's say selling points of Rust is that they are giving you uh, automatic memory management without, so you don't have to do malloc and
Malloc,
malloc
yeah.
and free. And so you actually it solves you two very big problems, which is use after free, and which is very very big problematic. And actually I think this and the segmentation for, so accessing values after the, let's say, the boundary of the array or the memory that you can access are about 85% of the issues that Microsoft had reported. So it's very, so use after free and dangling pointers are actually resolved for you. And the it is doing this automatic measurement without any garbage collector, and having performance very similar to C. And this is great, because uh, then he realized that, okay, this is what I need to use. And of course, if you analyze this, and also it's also, so another one is protecting you. For example, it eliminates the data race conditions, so you actually cannot do data. Okay, you can do race conditions. Is a bit different, but okay, similar but a bit different. But the race condition is a bit hard to have a language to protect you. But data race, so two threads accessing the same value, one writing, one reading, or both writing, it's not possible actually in safe Rust, let's say. Because okay, in unsafe you can do anything because it's normal. So they had to expose you also similar functionality to C, because it's designed to be able to write file system drivers, operating system, embedded code. So of course you need to have some low level stuff. And
Yeah, low level functionality. Exactly.
for this is the unsafe Rust. And in unsafe Rust, then okay, it's very clear that your intention is to write unsafe code, and you have raw pointers. You can allocate memory. You have to release it by yourself and so on. Okay, you have some helper with the box and so on, but you need to do it manually. And The idea is that the recommendation and good practices for unsafe code is to document it very good, very truthfully, and also document the functions that have unsafe code, not only the functions that are unsafe. And also the code review should be done very careful. So you should never spy. And there are, for example, there are libraries. There is one that I'm using for zeroizing stuff, which is called secrecy. And the idea is that there is this directive which is called forbid unsafe. So actually they don't allow any unsafe code. So if you want to really be safe, then you be on the safe side. Then you will not allow any. Okay, this means you do higher level logic, so you cannot do low level stuff. But it's a decision that you need to make. And he he of course went rewriting the C library in this, and he showed me the before and after code, and it was like one third of the code.
Oh wow.
And everything was looking cleaner, so everything was way cleaner. And he said it's very easy to maintain. I understand everything, and it's very easy to maintain. And he was learning it, so he, he didn't allocate, I don't know, a lot of time to learn and then he write. He was doing it in parallel, and actually he was having some problems with actually accessing data from multiple threads. And he actually noticed that he cannot do that. He tried a lot of variations. He didn't find anything. He tried with like he got to the problem that, for example, you cannot have two mutable references to the same variable, and he didn't found a way around this, which is good. Then he found the solution is to use channels, which is a very good solution and actually is the best. I actually prefer that instead of many times I prefer channels instead of mutexes. Okay,
Mutexes
for
or
very
channels.
simple variables, okay, mutex are fine, but when you want to transfer information, and especially when you have like a queue, so when you want to have a mutex over a vec, for example, use a channel. It's better, and it's the code is much cleaner, so everything is safer, so everything is best. And yeah, it has Rust has some difficulties, so it's not a easy language to learn. I don't recommend it as a first language to learn because it's quite it has some challenges. So the three
How was your first experience with Rust?
my first experience was so this colleague of mine sent me a link, and he realized that I was also would like this. So it was a link with a video with some guy that has a channel. It's called Let's Get Rusty, very nice tutorials. And the what he did is he implemented state pattern in Rust. So if you look at the classical state pattern in the Wikipedia or somewhere, you will see that it has a class for each state, and the transition are represented as methods in a common interface. So you would end up he was presenting like he was implementing like a password manager, and you have these two states, lock and unlock, and he was having, let's say, in the classical OOP implementation, you have the interface that has let's say list passwords method. And the idea is that in the lock state, it doesn't make sense to list the password because you don't have access to them. And what you can do is either don't do anything in the method, which is not very, let's say, is not ideal because the user could still write a bad flow code. So he could do something like lock, and then at some point he does like a list password, and he doesn't understand why the password are not listed, and maybe it's actually producing a bad logic in the code because he thinks that it has no password, let's say, and it's a bad logic then. And also it's not good to, so the state pattern resolve the problem of having ifs in the code to check with the state. And also you can, the other alternative will be to throw an exception, which also is a bit strange because okay, then the user will need to be conscious that, I mean, the developer need to be conscious that the exception could be thrown, so you need to handle exceptions. And he would still be able to call the method in an invalid password manager state. So ideally will be not to be able to call the method. This is the most obvious solution that you will do. And how he did it in Rust. Of course, you can do this in other languages too, but the idea is that what I said before is the normal ideology in the object-oriented languages, and in the Rust ecosystem, the idea was instead of having, so you have structs for the states, but instead of having a common trait, in this case, having a common interface, actually you have specific methods for each struct. So for each state, what actually you can do. So the transitions. So actually, when you do like something, I don't know, lock. You call the lock method in a structure that is let's say unlocked, then this will return you a locked password manager structure, and this locked structure will not have at all the least password method because you cannot do it. So it was very clean. So actually you use the strong types that the language gives you, so it's very very type oriented Rust, which is very good, and use the type safety, let's say. So you actually cannot write bad logic code. You cannot write a code that will do least password when you are in a lock state. So this is ideal. And of course, like I said, you can do this in other languages too. But the first solution in other languages is not this. But the first solution in Rust is this, and I of course I like it. But what I realize is, if they do this, so I said that there are small details. They pay attention to very small details, and I'm sure they will pay attention to other details too. And these very small details cumulated, then like the sum of all things. So the entire is the sum of all things. I'm sure there are a lot of these details that will be making the language great. And yeah, indeed there are. And I actually become to love the language. So after I have this, so there are these three difficulties, let's say, that Rust has in order for you to be able to write safe code. So, for example, Rust doesn't have a garbage collector at runtime, but how I see it, actually, the compiler is somehow like a garbage collector because it does stuff that actually garbage collector does, and also it needs help sometimes. For example, it needs help, so it tries to protect you from doing bad stuff with pointers by imposing the ownership model, which okay, is like, let's say, the first thing that is different. Like I see the function, I put there the variable, and then I see that after I call the function, I cannot use a variable anymore. What the heck? It was moved to the function, and okay, it's not a concept that you have in other languages. Let's say I'm not very familiar. I'm a bit, but I'm not very familiar with all the functional languages. For example, like Haskell. I'm sure that maybe
Yeah.
it's a bit harder to learn, but there are a lot of concepts that uh, are still different in Rust than other OOP languages. And for me personally, it was the hardest language to learn, even though I have like more than 20 years of experience. I have played with, I don't know, Java, C++, C Sharp, Python, Kotlin. So a bit of uh, no, that's it. Let's say let's resume to this. And the idea is that you have this ownership model which helps you to protect the memory, and then you have this borrow checker which helps with the references. And the actually the ownership model is a very very interesting very interesting how it's implemented with the resource allocation is initialization, so the RAI concept, and this comes from C, where they built also the smart pointers, but it's very
Yeah.
very well implemented here also. So the idea is that there is only one owner of the variable, and this could be the, let's say, the function, the scope of the function, or if you pass it to a struct, then the struct become the owner. So when the owner goes down, so like the function or the struct is deallocated from the stack. So this is the simple logic. You can see it doesn't matter where the variable resides, stack or heap. When the owner is deallocated from the stack, because no matter what you have, it starts from the stack. Even a box which is keeping the data in the heap, it has reference, it has something created on the stack. So when the owner function or struct, because normally these are the two ones that you can have, or okay, closure, but that's a function. When you have this owner destroyed, dropped, then it also will drop you the variable that he owns. And this is the main logic. And then there is in Rust, I didn't see it implemented, but it was implemented, I think, in Elixir. It's a functional language which I want to learn. It's from Erlang, and this is functional too. And uh, it has a nice characteristic with this RAI model. So just imagine you send the message to a consumer, and of course you send it, but you don't know if he handles the mail, or you put it in a queue and he consumes it, but you don't know if he consumes it. So what you could do is you create it, you pass the ownership to the queue. Then when the producer reads from the queue, it becomes the owner of the message. And there is a method like the destructure. You can actually have a method annotated somehow, and the idea is that before the message being destroyed, the compilers ensure that that message was called. Let's say get payload or something like that. And if the consumer called get payload, of course, normally it would have handled. Okay, if it's a I don't know. A bad developer and call payload and I throw it away. Okay,
Yeah.
you cannot control that. But the idea is that you somehow enforce the developer to not miss this message, because the idea is that the message cannot be deallocated and go out of scope if the get payload is not called. So this, for me, it's an interesting concept because you can ensure some logic, some functionality. It happened, without you needing to do, I don't know, some artifacts like, for example, you could do this. If you don't want to do it like this, you could do it with a callback or a notifier, so notify you back when it was consumed, like when you see on the chat messages that the message was seen or something like that. You see that it was read, or the email, they said that okay, the recipient read the email, but that's one more communication back. But if you do it like this, you don't need to, this could be decoupled. You don't need to keep them coupled. So it's very, very interesting, a concept which I will actually would like to see in Rust, because it's an interesting concept. And then you get to the, so borrow checker helps you a lot. And then the compiler is very smart. I think it helps you a great deal, but it has limitations. Okay, there is a new compiler that they are working on which is a bit smarter, but it has some limitation. And there are some cases where it's not obvious how long a reference should hold. And in those cases you do like you hint something to it, and this is what lifetimes are. So the idea is that lifetimes doesn't control how long a variable lives, although maybe you could think by the name, but actually creates a, let's say, a relation between two sets. So if you look logically in mathematics, if you take sets, there are sets and subsets, for example, and you can think at this as, for example, you can have the lifetime of the variable, which is needs to be longer than the lifetime of any reference. So actually, the references are all a subset of the big set. So you can actually represent this as a mathematically. In the compiler, actually, this is how it does, because it's simpler to implement. So it doesn't do it like a timeline or something. It do it with these sets, because these are very simple to implement in programming. And if you think like this, then you directly understand the lifetime extend. So you can have a lifetime extending another, which means that the second lifetime needs to live longer than the first one. So you can have all this modeling. And actually, if you, I don't know, if you see all these, uh, and also, for example, if you use like Java or Python, if you give a variable to multiple functions, what happens behind the scenes is like these variables are is like a variable, is like a smart pointers with reference count. It counts how many references are to these variables, and when the pointer gets destroyed, it decreases, and when it's zero, it knows that it can be garbage collected. Then actually in Rust, you could do this with RC, or if you want the thread safe, with the arc. But the idea is that is like, so for example, if you would write the garbage collector like that crazy guy, Korean guy.
Yeah.
So if you would to write a garbage collector in C, most likely you will end up having structures similar to RC, because you have the variable you allocated, and you wrap it in RC, and then you give the RC to the other that is calling it, and then you decrease it. It helps you. So, like, for example, using Rust is actually like you writing bits of parts of code of the garbage collector. So actually, like developing garbage collector. So that's why somehow I see that Rust doesn't have a garbage collector at runtime, but it has one at compile time. and you are actually building it, you're actually helping it. You're writing a code. Actually, are you writing a garbage collector part? Let's say. And if you see all these Rust complication, these three ownership, uh, borrow checker, and lifetimes. If you see all these in the idea that the bar ownership, all that it means is when the owner goes down, you go down, and the borrow checker is just a way to ensure that the references are valid, and the lifetimes is just helpful. All these for a garbage collector that you are using, so everything is like a garbage collector, and also you could even see it easier. So you could see all these. Uh, for example, borrow checker, how you could see a borrow checker, you could see it like a RW lock, so like a read write lock, because a
Read write
read
lock, yeah.
lock actually allows you to have multiple uh, immutable references, only one mutable. So read write lock is exactly a borrow checker. So I mean, the logic of a borrow checker could be incorporated in a read lock. So if you see all the variables are wrapped in a read write lock, you actually understood the borrow checker. You don't need anything. Then it's somehow, if you're a programmer, it's easier for you to see it like this because you are most likely familiar with this lock. You know? And if you see the lifetimes just as a hint for the garbage collector code that you are writing, actually all this makes sense. But if you just read the documentation, unfortunately, they didn't put it like this in the documentation. I read it somewhere, and it was easier for me to see it like this, to understand it like this. And actually, these three, I don't know, characteristics of Rust that actually make it great are the ones that, let's say, demoralize and make most of the people quit continue learning Rust. And actually, I have like quite some few friends. So we are like, I think, 6 or 7 friends that we all started to learn Rust. This guy with the audio engine was first to start. He sent to me. I started to learn. For me, it was maybe I'm not a good example. I mean, the best example, because for me it was a perfect situation, because I didn't work back then. At that time, I needed something new, and I was curious and wanted to code, and I really wanted something like that. And I
Yeah.
didn't mind it was hard. I actually like it. It was hard because, the Kennedy said when they go to the moon, we didn't choose to go to the moon because it's easy. We do it because it's hard.
Yeah.
Also, the satisfaction.
We want the challenge.
Yeah.
Yeah.
So, and I'm never afraid of a challenge. I like challenges a lot, and I'm the satisfaction is also directly proportional.
What was your first Rust project? So you're like, okay, I'm gonna pick up Rust. I'm gonna learn the ins and outs of it. Like, where did you start? A lot of people start with writing like static page generators or like smaller scripts. But what was your first Rust project?
Um, so I started to learn from the book, and I'm always I always need to learn the combination with some code. I cannot just read books and so on. And I said, okay, I need a project to keep me motivated, and then okay, I thought to some projects, and I had some ideas. Then I thought, okay, let's ask ChatGPT, maybe it will give me more. And ChatGPT started with a to-do list, and I said, "Come on, man, not yet another to-do list. The world doesn't need yet another to-do list." And
Yeah.
then he said like a password manager, which is decent. And then he said like a distributed file system, and I said, "Okay, this is interesting, but maybe it's a bit too hard for a learning project." And I said, okay. And the fun fact is, I'm now tackling the mysteries of the of a distributed file system and actually building one for learning. And then what I decided to go with, this was not came the idea didn't came from ChatGPT. I decided to do a distributed file system, and how this idea came to mind was I had a local folder with some data from the projects from the clients. It was not like it was like private data, but not like credential and stuff, because credential I keep in password managers. But it's, I don't know, requirements for a project, test cases, and so on, which okay are not ideal, not ideal, are not. It's not very bad if they become public, but it's not. ideally you would not want it to become public. Okay, so I wanted to access these documents from several locations, and what I did, I used uh, it was called back then, it was called BTSync. Now it's called Resilio. It's like a BitTorrent, actually from the BitTorrent creator. It's a sync client that actually uses BitTorrent to synchronize between multiple devices, peer to peer. And I used that, and I had like the disadvantage of this is that you need to have a computer or a server always on to be able to fetch the new data from. And it was a bit, let's say, problematic. And I thought that, okay, how would be to use Google Drive or Dropbox for that? And the idea is that, okay, it's okay for synchronization, but then they can read your data. Okay, it's not so problematic because I mostly trust Google Drive and Dropbox, but you never know. They get hacked. You never know. So I was thinking that a solution to have encrypted folders, let's say, it's very useful for me, and it will also be a very interesting project. So somehow it started building from a need of mine, let's say. And I think these are the best project to build because if you have some problem that you solve it, and if many people have the same problem, then it's a good product, and if
Yeah.
you solve problems that are also expensive, if they keep having the problem, then okay, you can make also money. So it's a good. I think it was a. I decided it's a very interesting project to do, and yeah, it really was. I learned quite a lot, and then at some point I decided to uh, continue to work a bit more, and I thought to monetize it, and then I realized it's a lot of work. I cannot do it by myself. I thought, okay, I take some freelancer, but I don't make money out of the project. Is not sustainable. It's not a good idea. And then I decided to write on some Reddit, Discord, and other Rust forums and user groups. And the idea was that I just said, okay, look, I have this project as a learning project, and do you want to contribute to open source? And there were quite many responses. And there were quite many people, and actually we are now quite a big community. We are like, okay, there are parts of community. For example, I did a presentation at a university in Bucharest to motivate
Ah.
people to come to programming, and then the professor said that he would like to have the students work on open source projects to help them become familiar with what does it mean in the real user case scenarios. And yeah, I gave them some tasks from my project, and there were like 12 people who got involved. And I asked them, okay, what is your experience with Rust? Everybody responded none. And okay, I said, okay, maybe it's a bit problematic. And I asked the professor, uh, look, these people doesn't know Rust at all, so they need to learn Rust. They need to learn cryptography, which is not easy either. They need to become familiar with the whole project, and then become familiar with the characteristic of their own issue that they need to. So it's four things that they need to learn, and they have like few weeks. How will they do it? Ah, don't worry, they will catch up. He just said like that. And I said, okay. They use a lot of ChatGPT, I think, and I told them, just ask me anything, anytime. I help you. And the idea is that okay, they didn't all perform well, but I had like 7 pull requests which were okay, and were actually merged in the branch, so it's quite okay. And also these are in the community because we use the same Slack, because I thought it's reasonable to have access to everything. And in the all of us are like now I think are 68, something like that.
68
68,
contributors
yeah,
right now.
let's say
Yeah, that's
68
pretty good.
persons in the community. And from all of these, like, okay, we have these 7 which at least contributed with one commit, but what I like is few of them remain contributors. Yeah,
Oh,
that's
that's
nice.
nice.
And then from the other people, let's say maybe like 10 or 15 are, let's say, active contributors. Most of us are developers, but we have some the DevOps guy that we collaborate with. We have a QA manual and automation, and we have a UI UX designer because we have also a desktop application, and we have mobile too. And uh, these, let's say, 10 are active contributors, and it's very nice because I really appreciate these guys, because just imagine uh, all this code that they write, I would have needed to write, so they actually help me.
Yeah.
And not only this, but okay, as a from the experience standpoint of view, I have the most experience in years, and I have better Rust experience. But they are very smart. And for example, there was a guy who wrote a bitwise bitwise operations expression, and it was like, I don't know, 15 characters of code, and it wasn't obvious for me what it does. And I give it to ChatGPT, and he explained me like, I don't know, almost a screen of explanations. And okay, I understood it. And after I understood it, I thought it's brilliant. And I told him, look, man, I think you did something brilliant here. And I told him, I give it to ChatGPT, and okay. And he said, yeah, yeah, but just imagine when I did this, I had experience because I did it before. And but when I did this before, there were no ChatGPT, so I had to do it by myself, and it took me like 3 or 4 hours to come to this correct expression. So he said, "You not understanding doesn't mean anything bad, and the fact that you understand it after ChatGPT explained you that is okay. But just imagine, it took me a lot of time it was like something like." We are using that secrecy crate that is actually ensuring the variables are zeroized. So you need to do this for the credentials, for example, and passwords, and buffers where you keep plain text data, so like decrypted data. And it didn't had, for example, so there is this concept of if operating system decides that there is not enough RAM, it moves some stuff to the swap file, and the swap file could be
Hmm.
unencrypted. You never know, so it could be on the disk unencrypted. So
Yeah.
what you do is this concept of locking the memory. There is a syscall called mlock, and you actually mlock your
Hemlock.
your memory, and then you're sure that it's not moved. But the idea is that you cannot mlock a variable, all only the bytes of the variable. You can only mlock by pages, so the whole page. And you
Uh-huh.
need to calculate, for example, based on the address of the memory, in what page does it reside. And just imagine you can have a variable that spawns on two pages. So you need to lock two pages. So he actually did like arithmetics to actually find the start page and the end page based on this. So it's just like, just imagine the simple arithmetics will be, you have pages of, let's say, size 10, and you have the address of the memory, I don't know, 23. And in order for you to find the
Yeah.
page, you just do 23 divided by 10, the page size, and you keep the whole part. So you have like 2.3, and you know that you are in a page with index 2.
Huh.
This is what he did, but he did it like bitwise. So he did something like, you take the page, the binary, and then if you do like if you have no, you take the page size. Yeah, you take the page size. Yeah, you take the page size, which is normally like, let's say, 4096, which normally is a multiple by two number. So you have like one followed by 12 zeros, I think. Uh, 124 is 10, 11, 12 zeros. Yeah. So you have one followed by 12 zeros, and then if you subtract one, you end up with this one becoming a zero, but all the zeros in the left becoming a one. So you end up with a mask filled by one in the right. And then what you do, you do an uh, you do an end with the you do an end with the value of the page, and then you actually only keep the, don't remember exactly the expression. So the idea was that you if you when you add when you do an end, then the last operation was a not, and you ended up having zeros on the position that is not multiplied by 2. So the idea is that you have zeros what is after 496, let's say. So after the page index, you have zeros. And this, if you divide by the page size, you actually get the page number. So you only get the page number.
Uh-huh.
You don't get the rest. So it was something like that. And yeah, from people like this you learn. So he also has like a project. he was starting to build distributed key value pair, and it is doing it with in a masterless way. So most of the distributed solutions are using one active master at a time, and when that master goes down, there is a quorum of the others, and they elect another one, and that one picks up, and this happens very quickly, like milliseconds of tens of milliseconds, and you don't notice it. And the idea is that if you have a lot of load, so all the writes, for example, to keep the data consistent. So this is how Redis works and all others. So to keep the data consistent, all writes go to this master. And the if you have a lot of load, you have a lot of throughput, you write a lot of values, hardware cannot keep up at some point. So you have a hardware limitation, and that's why it appears this concept of sharding also not only the data, because okay, it's easy to shard the data, but sharding also the processing, the compute, and then
Yeah. It's like
yeah,
load
load balancing for the
balancing
compute, yeah,
almost. Yeah.
and having
Yeah.
being able to process multiple calls, let's say in parallel on various nodes, on different nodes, and it's not easy to do. Believe me, it's a research field actually, and they have this concept. They have these two important concepts which are called CRDTs, are conflict-free distributed data types, and OP, like operational transform. Operational transform are used in for example in Google Docs when you write. So it has like three operations. It has like insert, which you have the cursor, and then you have insert, which inserts a character. You have like a move. I think it's called accept. So you actually move the cursor and you accept the next character. And the other one is delete. You drop the letter. And actually you record your changes based on these three operations, and then you send these operations to the other party, and then they replay it. And the idea is that it doesn't matter the order in which are they are replayed, the end result is the same. And because you cannot actually do it instantaneously changing the same character, always there is a delay, and it's executed based on the timestamp. And if you rerun this everywhere, you get the same result. So this is easy to do, let's say. And the other ones are, they are having various type of structures. The only one is called grow only set. So imagine you have a set of integers, and the only operation you do is add to it. And it doesn't matter the order you add it, like 1 to 3 or 3 to 1, you end up with the same set. And
Oh.
this is easy to distribute. But there are others which are not. For example, just imagine you also remove from the set. So this is critical when you do the remove before inserting an element or after. So it's a bit complicated, and you need to find the right structure. You need to extend it. So there is always a compromise, like always in programming, and
Yeah.
you always need to choose the one that fits you, but you always need to accept that you made a compromise, and there are situations that it doesn't cover. Then one popular and famous compromise, it's called the cap theorem, and the idea is that the P stands from partitioning. Partitioning is in the idea of a network. So the idea is that it doesn't matter what you do, you cannot have you don't escape the fact that you can have some network failures, and some nodes could not see the other nodes. Given that the nodes are alive, they cannot see each other. So normally uh, what it happens is, if you don't do anything to handle this situation, is each of the, let's say, partition notice that the master is down. I mean, one partition will notice that the master is down, because the other, okay, will see it. And this new partition will elect a new master inside the partition. So you will end up with two masters, which is a split brain. This is the split brain problem. And normally, how you prevent the split brain problem is, you always need to have a odd number of nodes, and you always check when you don't see the master. You check if you see half plus one, including you, of the nodes. If you don't see, it means that you are in the smaller portion of the partition. So you decide that you stop accepting messages, because otherwise you compromise the state, and only the other one will accept that. what happens if you do this is you keep the consistency, so you choose to keep the consistency, but you lose availability because only half, let's say half plus one of your nodes could handle the load. And most of the solutions where the consistency is needed are using this. And the other approach is to, so this is the C from the cap, so is the consistency, and the other one is availability. So you could choose, for example, availability. You decide to leave both partitions handling nodes, but you need to accept the fact that you could end up with some inconsistent state, like I don't know, having a file with the same name on both of the partitions. And there are, for example, solution where this is acceptable, or it's acceptable for short period of times, and then there is this concept of eventual consistency. So you can be out of sync for a period of time, but then eventually you will convert to the same state, so you are consistent again. This is eventual consistency. And the idea is that on joining the clusters again, so you do like a merge. So you do like a merge, you have a conflict, and then you can resolve the conflict. For example, if you have a file with with the same name, given it, for example, you do a file system, you could decide, for example, maybe one file is empty, maybe the other one has content, you can keep the content. Or if they have I don't know, if you do changes, so not like Git does. So if you change on different lines, it accepts both. But if you
Uh-huh.
change on the same line, or if you have a file created with content different on both sides, you need to choose one, and most likely you choose the most recent change, the most recent one created. So then, okay, there are situations, but there is always, I mean, there is not a perfect answer. So you need to choose. That's why the cap. So when P happens, the partition happens. You need to choose between consistency and availability.
How has RenFS or your distributed file system like tackled that? And like what crates have you used to build it? And how is the like architecture right now?
The rank FS is just for so the rank FS is just doing encryption at rest. So this doesn't tackle the distributed problem, and also it doesn't uh, it doesn't do synchronization. So you could use the uh, rank FS to have the data encrypted and use it on multiple devices, but the synchronization is for you to handle. So you could use Google Drive, but we don't handle this. But we have a RFS project, which is the for a Rust distributed system, let's say.
Huh.
And the idea is that uh, we use the so how I was thinking. So we could use, so normally, given that it's a file system, I would go with consistency. But
Yeah.
there are cases where maybe I don't know, uh, you store, let's say, some data that I don't know are from books or stuff like that, or blogs or stuff like that that you use to train a LLM, and the data is not, let's say, so critical to be in the exact shape that you read it. So you could have a trimmed, I don't know, comment, or you could have a comment with some different words at the end, but the idea of the whole comment, the sentiment of the whole comment, the meaning of the whole comment will be most likely the same. So you could have cases where it's not so critical, or I don't know, if you have a temperatures, and if you have like you want to do an average, you don't care if it's a 2.1 or 2.2. It's decent for you. You don't
Yeah.
want to be 100. And in those cases, you may prefer availability. Let's say you have a lot of sensors, like IoT sensors, and they are collecting a lot of data. And how I design it to do is it's a configuration step. It's a setup step.
Huh.
So you can prefer, for example, you say that, okay, my cluster is doing availability or consistency, and to do it more granularly, if you are building a file system like this is, you can do it at a file level. So you can decide, okay, this file or this folder is for availability, and then we'll have like two subclusters, which actually it will resolve internally the logic based on the type of cluster they are. So if there are availability, all the nodes in the cluster will always be available. So I leave it like by default we'll fall back to consistency, but we give you the invitation to configure it how you want. And most of the stuff that we will implement in this RFS is configurable. So in the idea that, for example, uh, the the sharding algorithm. So how you decide? So we split a file in chunks, let's say, and we distribute the chunks in on various nodes. So this is sharding. So each chunk is a shard, and there are various algorithms. So the simplest one to implement is like just you have like, I don't know, 10 nodes, and you just do the offset of the chunk divided by 10. So you
Hmm.
divide by how many nodes you have. But the problem is when you increase the number of nodes, then your logic is broken. Or when a node goes down, your logic is broken. So then you need to move a lot of data.
Data. Yeah.
Yeah, you need to move a lot of data. The other approach is, for example, there is this concept which is called consistent hashing. And what it does is like uh, for each for each node, uh, it uses some. You need to have a unique identifier for the node. So, like, let's say you have the host name or the IP, and it does a hash, and then uh, you distribute this value on, let's say, a ring or a circle. Let's say you distribute it modulo 360, so how many degrees are on a circle, and actually you get some points. You get the point where the hash for the node corresponds, and then let's say you have three nodes, and then you have like you do a hash on the, let's say, the file name or something unique for the file, and then when you do the hash you find let's say a point. Most likely it will not be the same value as the node, but you then look at the node going to the, let's say,
Yeah.
clockwise, or you can choose, doesn't matter, you go one way, you always go clockwise, and then
Huh.
go clockwise, then you actually will find the closest node that is based on the value, and actually you will put it there, and you do this the same, and this will actually give you a pretty even distribution. Problem is, depending on the hashing and on the value of the node, you could end up very uneven. So I mean, you can have some hashes located close to value 0, and only one located to, I don't know, 180, and you'll have a lot of files put on the node closest to the hash 0. And what normally do is you create virtual nodes, which means is you take the, let's say, the IP of the node, and you just add 1 2 3, like a suffix in counter at the end. You hash this, and if you do this, then given your hashing function is good, and is doing a uniformal distribution, and ideally you could use like a cryptographically safe hashing function which actually ensures you that doing a even distribution, you will end up with even nodes on the circle. Of course, most of them will be virtual nodes, but it doesn't
Yeah.
matter, because if you hit a virtual node, it corresponds to the real node, so you know the real node where it should go. So actually this will give you a pretty uniform distribution. What happens is, if one node, for example, goes down, you only need to move uh, the data from this node. So you rehash again the data, and you will see where it will reside, and it will be distributed to the other nodes. And the same when you add a node again, you redistribute the data. So only let's say, normally the neighbor nodes will get affected. And this is pretty good distribution. Let's say a penalty would be that you always need to do this calculation, and you always you need to keep them somehow in sync, all these values. So you need to know all the time how many nodes are available, there are IP, and so on. And another one is called key range. This is, for example, what MongoDB does. uh, what you do is you allocate uh, for each node. Like, for example, you have the values that you want to distribute, like rows from a table based on the ID, and the ID is like I don't know, int or something. And you distribute. Let's say you have three nodes. You take the interval of from 0 to max int, and you have three ranges, and each range corresponds to a node. And then you
Okay.
take the
So you split the data depending on the range of the index
yeah,
then?
and you
Huh?
don't directly use, let's say, the index. I mean the ID, because if you have an auto increment, it will use the only the first range a lot of times. So you just hash the ID based on a uniformly distributed hashing function, and most likely this will give you a even distribution. So you'll then
Huh.
split the nodes. And the beauty of this model is, for example, if you have like if you allocate a new node, what happens is that new node will reside in an existing range, and what you do is like an interval. You just split the interval in two, and you have two more small ranges. And this half corresponds to one node, half corresponds to another. And the data from this node that was owner of this range, half of it you move it to the other node. So you just need to move half of the data from one node. And when the node goes down, what actually happens is you have two ranges. Imagine you have three ranges, and the middle node goes down. You just union these two intervals, you
Uh-huh.
intersect them. And actually, what is happening is the data that was on this node, of course, you cannot access it, but you have it copied on other nodes because you replicate it. You know what IDs should be on this node. You take those IDs from the other nodes and you copy them to this node that actually is incorporating the other one. Because if this goes down, this one will take the other one. So the closest one will incorporate the other one. So it's the same. You just need to move the data that corresponds to one node, which is obvious because you need to move that data that was there. You need to copy it, not move it, copy it somewhere. So it's obvious.
Yeah, you need to
Yeah, and
replicate
this
it.
this actually minimizes the operations that you do, and this could be very very efficient. And this also helps you. You don't need to do so much calculations either, like the hashing, the virtual, and so on. So it is a bit let's say performant. And the the and also it's very abstract. You don't need to know anything about the node, so it's like let's say an abstraction layer. And the idea is that, okay, based on your situation, you could pick one or not. For example, if you always decide to go with a static cluster and always keep the same amount of nodes, and if one node's down, you replace only that node. I think the first solution is better because you just do a modulo, which is very fast, which is very decent. And uh, also this, I want to make it configurable. Of course, this you cannot change. Okay, you can change after you set it, but it will perform a lot of moves to real.
Yeah.
But the idea is that you can configure it, or the same. You could have like clusters. I mean subclusters based on the some files. You could have it like using one hashing or another, one sharding algorithm or another, and it will know, and it will put on the corresponding node, so you can actually configure everything. And now I did the implement. Well, unfortunately, we don't have a lot of time, and we don't have much done on this project. So I did this consistent hashing and other shard distribution algorithms, so they are working. Just where you don't have yet the actual logic to distribute a file, to save a file, but we'll
Uh-huh.
only inject this and we will use it. And what other things that we think it's nice to do? So given that we given that we replicate the data when a new node comes or something like that, or I don't know, a node goes down and you want to take the data from other nodes, it makes sense to use BitTorrent because you could read from, let's say, 10 nodes. And uh, BitTorrent is designed to work by default with TCP/IP, and we want to use UDP. And we thought that, okay, I like very much the quick protocol that Google developed, and it's now in HTTP 3. And
Yeah, HTTP3.
yeah, nice. And
Exactly.
I was thinking to use that, and okay, I investigated the solutions, and we found this called Queen Crate, and then
Queen crate.
yeah, it's like and then there are others. So there is a leap P2P that they have, or also are using quick to transfer the data, and there's also one more IROH. crate which I like is the site is iroc.computer, because if you just look iroc, I know you find some very strange stuff. So this iroc, for example, it tries to do something similar to IPFS, but somehow better. But now they are mostly focused on just transferring the data, not storing. They have this concept of blobs, which is in beta now. These are like parts of a file. You could emulate files with it. And okay, we wanted to use this, and we said that okay, let's use a popular Rust BitTorrent client, and we found RQBit, I think it's called, and we said okay, let's add a quick in let's quickly add quick in the RQBit, and then we wrote to the owner of the repo, and he said, yeah, it's very nice you want to do this, but there is a standard in the BitTorrent protocol which is micro TP. So it's a lightweight version of quick, and it's somehow optimized for torrents. That's why it's micro TP, not DP. And
And that's UDP based.
it's UDP based. So actually
Okay.
it offers what quick offers you, like retry, package congestion, and also ordering if you want. So all these are offered, but it's very lightweight. So not, let's say, not maybe as performant or something like that, or like quick, and not so reliable like quick, but it's decent for this for torrent. It's quite nice, and yeah, we decided to implement that, and actually one contributor is working on that, and I said, okay, let's not reinvent the wheel now. Find a library that has UTP and just integrate it. And he only found libraries that are sync. So he didn't find any async library with using the concurrency, and he didn't like that, and he decided to write one by himself, and actually wrote a UTP implementation from scratch using async, and actually it is working very nice. And we implement that. It's not yet finished. I need to do the code review, but it's working in his dev version of RQBit, and actually first time he started RQBit, he tested because we wanted to decide which client to use. And when he started first time the RQBit, it was not downloading from any clients. And he had a local client, a torrent that he made. So he tried with another client, and that client worked. And the idea was that all these other clients were using because nowadays seems that many modern clients are using this UTP, because okay, it's not a revolutionary idea that I had to use UTP. Okay, it is a good idea, but not a revolutionary one. And all these are implementing this, and I don't know for what reason they don't fall back to TCP if you don't have UTP, which is strange. And seems that was the problem. So after he implemented UTP in the BitTorrent, all other clients were sending data to him. So that was the issue. And yeah, it's pretty nice that now we'll have a contribution back to the. We also keep this as a separate crate if you want to integrate it in another solution, but we also offer it as a feature in RQBit torrent, and then we'll will
Oh,
benefit. The
that's super
community
nice.
will benefit from it.
That's really really nice.
We
What?
like to have to give back to the community.
Yeah, that's the if you're programming something that's useful or you get like a nice feature for something you forked,
Yeah,
like definitely go upstream with it. Like try to get it into the main repo. Then you will help like so many future developers.
yeah.
So yeah, we touched upon some crates there, but if you have to like cherry pick some of your favorite Rust crates, or maybe there's some Rust crates that you think are like not enough people are talking about them, and you find that you think they're very very useful. Like, what are your favorite Rust crates, and what are some hidden gems out there?
Yeah. So of course there are these very popular one, which that's why they become popular because are great. So for example, I like a lot Clap, which is the
Clap,
line
the
command line
CLI.
parser. Yeah. So the CL,
Yeah, yeah, yeah.
which is great. Then of course, given I'm building a cryptography solution, I like Rust Crypto
Rust
collection
crypto.
of crates, which is really great. Actually, now I'm using Ring because okay, this is what I found that is most common, but I have problems when I'm trying to build. So with Ring, it's interesting. So it originates from LibS. Yeah, Lib.
OpenSSL.
OpenSSL from OpenSSL, and Google forked that, and they created Boring SSL, and the Ring guys actually, I think there are some developers from Boring too. They are using the code from Boring SSL, and they are contributing back, and it's like 29% it's assembly code in the Ring library.
Yeah.
Another 20 something it's Rust, no, it's C, and the other is Rust. And the problem is that assembly code is okay, platform specific code, and the problem,
Yeah, they want it to be extremely
yeah,
performant and fast. Yeah.
and I can confirm you. So actually, this is, I remember now. This is why I use Ring because I did some benchmarking with Rust crypto, and for example, on my laptop, which is not great, and I don't have a very good SSD, so I had like with Ring, I had speeds like 2.3 gigabytes per second, right? And with Rust crypto, I have like 700 megabytes, so like more
Uh-huh.
than three times
That's
less. Yeah, it's quite a big difference. And okay,
yeah.
I understand it's because of that. Maybe they are also using some because it depends also on the cipher that you use, because and the hardware. For example, what I learned is that so I support now AES, Advanced Encrypted Security, I think what it's called, or and Cha 20. And
Yeah.
the idea is that AES is very old, and it's supported by a lot of also the government, and NIST also recommends you this one. And the idea is that it has a lot of hardware optimization. So you have like hardware specifically designed.
Oh yeah, AES, NST. There's a lot of like system Intel as well, and AMD. They have a lot of like hardware optimized solutions for it. Basically, so you can use the hashing functions. You can use the block ciphers like really really fast because they have written it in assembly,
Yeah.
which is like yeah the fastest of the fastest.
Yeah.
What's really cool, like a side thought, is like the RISC-V processor. Like is for people that don't know, RISC-V is you have different instruction sets on your CPU. You have Intel, you have Power, you have all these, and there is like a simpler one that is open source. RISC stands for Reduced Instruction Set, and it's basically an open source CPU, and they're building. There's a lot of development happening with the hardware optimization for crypto with RISC-V processors, which is like super cool. I know there's a project with the Blake-free hashing algorithm and RISC-V optimization. So there's a lot of like cool that's happening on the hardware as well,
Yeah.
but also in both cases because people are building hardware to break the crypto as well, not only utilize it. But yeah, it's
Also
it's a side thought and another
virus, antivirus,
discussion.
thief, police problem.
Yeah.
All the time it is happening. Yeah. So these hardware optimization are quite nice. And by the way, I think risk is used in ARM processors also.
Maybe I don't know.
Because I know
ARM.
ARM was designed also for reduce energy. So
Yeah.
there was an interesting story. So they had like a ARM CPU, and then they disconnecting it from the wire from the electricity, and I don't know, somehow it was keep on processing calculations. So without the electricity, what the
Huh.
fuck? And the idea was that the the
Magic.
magic, the energy from the vacuum, so the quantum oscillations, and the idea was that they found out that the residual energy that remained in the condensers, no, capacitors, yeah, capacitors,
Capacitor.
remained
Yeah.
in capacitor, it was enough to perform a few more operations. It was very interesting. It's very, 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 very optimized. Also, the instructions are also optimized. So yeah, I think it's really nice. And you have nowadays you have like operations like this, so parts, maybe not the full cipher, as cipher, because the algorithm is a bit complicated. So this is another advantage of Cha-Cha, because the Cha-Cha algorithm is way simpler, so you could even even teach it as an academical solution to understand ciphers. And actually, I want to build a cipher, okay, just for the fun of it and for understanding and for education of it, and to teach others. And I will do something based on Chacha because it's easier. And
It's really fast as well. Like a lot of like I know VPN providers right now, like WireGuard project uses Chacha, and everyone used to use the Chacha 20 Poly something, but now people are also switching to the Chacha 20 Blake Free, which is like Blake Free is this hashing algorithm, and it's purely implemented in Rust. But if you're a developer out there, you should definitely use the Ring libraries, and you use like audited and tested cryptography libraries, and try not to run your own cipher, at least for production stuff.
yeah, so this is for sure. So I'm very pro this ideology, so not to run your own cipher for production stuff, but I'm very also I also like to learn about them and to
Yeah, play around.
write your own to understand about them. And the idea is I had like a bit of negative experience. I wrote on a cryptography channel about this project of mine. I posted it, and one guy responded, "Oh, this is a bad idea. You never write your own crypto or something, cryptography."
Yeah, it's a big
Yeah,
no-no.
big unknown. And I said, okay, man, I understand, but I didn't do that, first of all. So I use audited, well-known sources.
Libraries.
So I didn't wrote my own crypto. Of course, you can use them wrongly because, so there are, for example, there are ways to uh, enforce you to use them, let's say, correctly, but then you are limited to what you can do, So then, for example, there is in the leap sodium implementation, there is I think it's called secret box, and it's only exposing you something like encrypt decrypt, nothing more. So, and for example, in the in the ring and in the Rust crypto one, you have methods like seal in place and open in place, which is like encrypt decrypt, and you need to provide, for example, the nonce. And for the
Hmm.
one of you who are familiar with the nonce, it's very important for most of the ciphers to use a unique nonce. So the combination key nonce message needs to be unique. If you fail to do this, it can end up in a catastrophic failure, which means that not only they can find out the parts of the message, they could find out parts of the key, which is
Yeah,
this is catastrophic.
yeah. The nouns is like really
Yeah, yeah.
keen in mixing the bytes
The,
and making
the
sure
nouns
like it actually stays encrypted.
actually the nouns is the key, you know, like a joke, because
Yeah.
the key in this
So
whole thing. Yeah, it's very important, and the idea is that you could use these ring Rust crypto well audited ciphers, but you could use the same nonce, and you failed the encryption.
yeah,
Also, there is this concept of so there is this concept of cipher. So cipher does the encryption, and cipher is not enough. So a simple cipher is not enough. A problem arises, for example, just imagine you have like uh, like a text, and you ciphered it. You have the cipher text, and then an attacker. Let's imagine you cipher a random number, so you don't have any structure.
yeah,
Because if you have you understand, but if you have structure, you can deduce that the data was mingled with. So, but if you just just encrypt a random number, and you just put the bits there, and then what happens is the attacker modifies some parts of the cipher text, and you decrypt it, and you don't know the the value is not correct. So actually, you would end up reading wrong information. So the the attacker cannot change it in a way that it can control what you will read, but it can change it in a way that it can know that you for sure will not read the correct value. And if you have like a logic, like if you read a status or I know of a HTTP call, and if you expect okay or zero or something like that for a command, it will change it that you will never get a zero, for example. Or I mean, for the command that actually is zero there, you will not read zero.
Uh-huh.
And actually it's breaking your logic at least, so you have a problem. And the idea is that it's not enough to use this. And what solutions they did is, so for example, a cipher is like like a cha-cha 20. And actually it's is derived from salsa. I think that guy really like dance courses. Like salsa cha-cha. Maybe he's
Yeah.
from Spanish or something, or Latin American. And it's funny. Parenthesis. It's funny with this. For example, also in Java there are a lot of libraries called also Java is like an island in Indonesia. And I think
Yeah, yeah,
the
yeah.
guys who work in Java, they like a lot Indonesia, because there is also a Jakarta framework, which is the capital of Indonesia. There is also a
Hmm.
Lombok library, which is an island in Indonesia. I think they liked a lot. And there's also, I think they also had a girl there that they like a lot. There is this Tomcat framework that is called the Catalina. Catalina. I think
Catalina.
they like this Catalina a lot. So I think
Uh-huh.
in the holidays they go there, and when they come to program, what name do we put? Oh, let's remember something from the holiday. And put the
Yeah. What's the best thing ever? That's
what the best thing I did? Who was the best person? Oh, Catalina. Oh, I remember. I think because, but maybe it's a good way to solve problems, because there are two of the most difficult problems in programming, which is naming things or no. You do a lot of renamings and refactoring, and then is the cache eviction. When you evict from cache, that's also a very hard problem to solve. And there is no, it's like the cap theory. There's no perfect solutions. You need to make compromises all the time. And yeah, so in Java they have this. So the cipher is called the Cha-Cha 20. And then what you normally do is like the logic that you are all familiar with is called the message signing. So you somehow sign the message, and you obtain like a code or something like that. And actually this code is from MAC, so Mac is called message authentication code. And normally you don't just let's say do the hash over the message, because you could do the hash over the message. But the problem is that an attacker could do similarly. So he could fake, so he could forge a hash to look similarly. Because I mean, if you do a hash over the cipher text, then he could do also on the modified cipher text. And what you normally do is called hmac, is called like hashed message.
message
Actually,
authentication code.
yeah, actually in combination. So because I didn't say it quite correctly. So normally you use Mac. The Mac, you do the Mac like a authentication code, but that's why it's called authentication, because it's, let's say, similar like a Mac, but it uses the key to produce this value, to produce this code. So it is based on the message. Let's say you could take the hashes of, for example, you have a HTTP call. You could take the keys and values from all the query and the body, and you could combine them. And you use the key also. You have the key participating in this. So on the other side, if you have the same Mac, then you can ensure that the producer of the Mac was owning the key, was in possession of the key. So
So you create like an identifier in order to identify it.
identify,
Yeah.
and this is the authentication side. So you authenticate it. So
Yeah.
and then you use hash, because hashmag normally use like to simplify the operation. You hash like for example, you can hash the ciphertext, and then you do
Yeah.
a mac on this hashed value. And normally you can read on Wikipedia, but the algorithm it's a bit more, let's say, it's like a three step. So based on the key, it generates another two keys, and with one key, it codes half of the message, the other half, it hash it, then the hash value, it's encrypted, it's hashed again with the first key, and then it hashed again with the latest key. So in the end, we end up with something that pretty much demonstrates that it pretty much authenticates, so that demonstrates it's you. And this is what normally you do with this ciphertext too. And there are various. So AES uses the GCM. GCM is like a polynomial. Polynomial function is a Glacco is something counter mode. Glacco is counter mode, and it's a bit more complicated to implement. And the the guys from the Chacha decided to use poly 1305, which is also a polynomial function. The idea is that's very interesting. So before I was so familiar, or more familiar, I cannot say I'm so familiar, because I was more familiar with these ciphers and the hashes and so on. I was always looking. So for example, when I configured to use a cipher or a proxy to use a particular certificate type, I was always seeing very cryptic, all these codes like AS, Cha-Cha 20, Poly 1305. What the fuck are all these numbers? No, and actually, the Poly 1305 is like it's a polynomial function in a space of 2 to the power of 120 modulo 5. And this is actually the mathematical model that gives you this function, this hash function. And what it actually does is it's taking is making a hash over the ciphertext. So you don't need to do of the original text. It's making over the ciphertext, and it produces this hash, let's say, or it's called tag, and it has like 12 bytes. And you take this and you append it to the message, and then you transmit it over the wire. And this is, if it's a hash, it can be public, no problem. And you send it over the wire, and actually what you send over the wire is normally the ciphertext, this tag, and the nonce that was used to encrypt the message. And because it's needed when you decrypt it, all these are public, so they can be read. You don't need to. Initially I was thinking how to make the nonce private, but then I read that it said that it's like, I don't know, uh, encrypting twice, so it doesn't offer much more. If you use, for example, if you use a weak cipher, if you encrypt twice, you don't add the security, because I can just do the brute force again, and it's not so problematic. You add a bit,
Yeah.
of security, but you don't add a lot. It's like, for example, there is this good example. For example, uh, the sun cream that you put. So the sun cream has this SP, or I don't know how it's called, the factor of protection. So that factor of protection is like the granularity of a filter. So it means how. So it's like on your microwave. If you look, you have like a grid which holes, and actually the length of the diameter of the hole is directly proportional to the wavelength of the microwave in your microwave, because the idea is that uh, wavelengths bigger or higher bigger than larger than that diameter will not escape, smaller will escape, and it needs to be proportionally corrected. And the idea is the same with the filter. So you can see the solution, the cream, like that filter, and the sun, it will get filtered by all the wavelengths higher than that. And for example,
Wow.
if you think that, okay, I take a factor 25, let's say, cream,
Like the bit
and I put
length. Yeah.
twice as much, you think, okay, this is like a 50, but it's not, because you have the same big holes, so the wavelength which are smaller than this will still go past to that, because you can have holes that are one after another. So the wavelength, you don't have a problem crossing those both. Well, the,
Yeah.
the same is like if you encrypt twice, or if you put a password twice or something, it doesn't help a lot. So okay, it helps in some cases where let's say is not, for example, where it helps. So You could, but it only helps if you have a very big difference. So, for example, if you encrypt, I don't know, 60,000 times, it will help a lot. If you help a bit, because what's happening, for example, if you, like I'm using also, so there is this concept which is called the key derivation function. So you can have the
Yeah.
KDF. It's like from the password, I cannot directly use the password to encrypt because the encryption key needs to have a specific length. And if I use the password, okay, if the password is the same length, okay, I can use it. Most likely it will not correspond, not match. And what you do, it's actually, the algorithm is simple. You just hash several intervals, and the idea is that you take this password and you derive a key that, and you specify the length. You can even increase it or decrease it, and you could it does a lot of hashing. And the idea is to, if you think a bit, so uh, if you were to derive a key of 256 bits, then you have 2 to the power of 256 combination, which is a very large number. But if you just use a password, so no matter what password you put, the uh, the values, I mean, you don't have a space of password of 256 values. Normally you put password, I don't know, 20 characters, 30 characters. So I can brute force the password. I can do the key derivation function for each combination of the letters to give you the password, and I can try this. So the idea is that I have a subset, a very smaller subset of possible keys that than all that are possible for the space of 260 bits. And in order for me to protect against this, I make the key derivation function hash like 60,000 times. This is the default in, for example, Argon 2, which is recommended to use for this. So you hash 60,000 times. So then actually it makes it harder. I mean, it takes more compute, actually 60 times more than. Okay, it is fast to hash also with the modern CPU, and you mentioned the risk and so on. The idea is it is fast, but it is slower than you only do one hash, and it helps a little bit. And this is what, okay, there are recommended practices to do. And
Yeah, I mean the goal basically being that you wanted to make it so like power and resource heavy that the attacker will just give up and like stop trying to figure out your
I
password
think
a bit.
I read somewhere there was some calculation on the AS 128, I think, and they were calculating compared to the cost of EC2 instance, and they calculated how many EC2 instance you need to take. It was CPU, okay, and GPU maybe it's less expensive, but the idea was that they were calculating how much it will cost, to break a 128, and it was like in the order of hundreds of trillions of dollars, and it was taking like, I don't know, I think hundreds of years or tens of years or something like that. Okay, you could spend like, I don't know, millions of trillions and reduce it to tens of years. Okay, so but
Yeah,
anyway,
it's not very
not
realistic.
to the
But then again, we have like quantum computers coming, but
that,
that's like
that,
that's another like giant rabbit hole
we
to
can discuss about
jump down
we can
into.
discuss about that if you want a little bit, but that's a different way that they do it.
Yeah, I think that's a different interview.
Yeah, yeah, could be.
But let's switch wheels a
Just
bit. So,
just to sorry, just
yeah,
to just to finalize, because for, I don't know, cryptographic enthusiasts there, uh,
yes,
you if you were to, I for example, I have a presentation that I did somewhere about the basic of cryptography, and I said, if there is one thing you need to take home from this, just take that, uh, always use uh, authenticated encryption, so AEAD, because what this authentication part is, so you see the problem with, if I change the cipher, I cannot detect it. I need to add this tag. So this is authenticated encryption, and the AD stands for additional data. So initially, I didn't understand the advantage of additional data. So what you could do, the documentation said something like, you could specify that the file is a PDF or an image, and you embed this in the tag, in the hash. And kept thinking, what does it help me for? Because I can see it's an image. I can put this field anyway. It didn't make sense. Why this help? Because it's not very obvious. Okay, and then I had this problem of uh, just imagine I have the file. I split it in chunks and I encrypt each chunk as a separate message in order to be able to seek very quickly inside the file, not decrypting the all the previous content, so that if you look at the movie, I can seek at the middle of the movie and you don't notice it, and I can look it. And what is happening if you take, for example, one block, one chunk from here as an attacker and move it somewhere else in the file, I cannot notice it. So if you alter the content of the block, I can notice it with the hash that is added as we discussed before, but I cannot notice between the chunks because there is no relationship between them. Everything is like a separate message. And actually this is like, if you look at the whole file as a message, it's like me altering the ciphertext, because I alter the ciphertext. I move around, no, and you don't notice this. And uh, how I fought to solve it, and this is where additional data came to help. When am encrypting it, I keep an index of each chunk, and I add this index in the additional data in the hash. So if the attack,
Yeah.
when I decrypt it, I use the same index that I'm increasing, and for the corresponding chunk, I use a corresponding index. And if you move the chunks around, so if the data is from another chunk, the hash is from the other chunk, then it will not match the index, so it will fail. When I hash on decryption, it will fail, so I catch it. So then this prevents me from moving the chunks around, and then you could, let's say, move the chunks keeping the same offset, but between files. So
Huh.
between files, and then for this, of course, obvious solution is use like a file ID or something unique per file, and then you include this also in this hash that you are doing, and then in the end you end up with this secure solution that is offering also integrity, because this is also good, because if the data was let's say changed by, I don't know, some hardware failure, hard disk failure or something, it will also, you will also catch this. And yeah, and actually this this is quite interesting, the break tree function. I like it a lot. And the idea is that it also, I like very much also the Merkle tree. I like a lot, and how you can verify the content of a file. I mean, the integrity of a file, and also actually, Merkle tree is used in BitTorrent to identify the chunks that need to be synced.
Yeah, and then there is different types of myrtle trees and mountain myrtle trees, and yeah, that's a deep rabbit hole to go to, but definitely worth checking out. And we will put some links in the show notes. So you gotta tell us about you're doing Rust courses now as well. Tell us a bit about that.
Yeah. So how this idea came is, I mentioned that when I learned Rust, there were some, let's say, difficult times learning it, and there were periods. I mean, one time actually, there was one time when they had like it's called impostor syndrome. Maybe you are familiar with it. So the idea is that
Yeah,
you
sure.
feel less than the image that you have in the, let's say, between your friends or in the society. So the friends, let's say, think you are smart and you think you are stupid. Okay, these are the extremes, but you think less smart than they think about you. And the the idea was that when I was learning about all these borrow checker ownership and lifetimes, and then entering a bit the smart pointers. Smart pointers actually I understood, they were quite nice, and actually I prefer when I want to simplify my life and not get into the not have a lifetime existential crisis, let's say. So not have problems with the lifetimes. I prefer to use Arc most of the times, because most of the time I'm doing async code, so most of the times Arc is the preferred way to go. Arc and Mutex, let's say. I use Arc and Mutex,
Yeah,
and life lifetime
keep it safe.
lifetime goes away. Life is easier, let's say. Okay, I
Yeah.
understand I'm a little bit less performant, but what can I say? You need to do something, also something else in life, not just spending doing. Because if you really want to do the maximum performance code, I don't know, you could write one and zeros in memory. No. You could do assembly or even more, write one and zeros.
Yeah.
So it's
Yeah.
crazy. Yeah,
x86 or something like
yeah.
that. Shell code,
Maybe
probably.
you've
Maybe.
seen the movie the Martian. There was this.
No, I have
Was
not actually. I don't
You
think so.
should look the
Maybe.
Martian. So there was this guy that was left on the Mars. They the planet. They thought that he was dead, and somehow he was not. And uh, I don't think it's a spoiler, but the idea is that somehow they found a way to communicate and send him data through, let's say, a kind of Morse code combining the ASCII code, and at some point they send them instructions of how to change the binary code of a Martian lander to use better antenna from the lander. So the idea is that they send him a diff, a patch, a binary patch encoded in ASCII, sent over, let's say, uh, Morse code
Long.
encryption, Morse code encoding, and he actually changed the bytes in the program. So it was like
Uh
bytes
huh.
around. So
So
it's
yeah, it's like
interesting. You should,
messing with the ciphertext almost.
yeah,
Yeah.
yeah,
Yeah.
it's quite interesting. And so the idea was that I thought that I'm not good as a developer that is needed for Rust, and okay, maybe I should pick something else. And then I realized if I look back, I'm not that stupid. If I look back on what I did, and okay, if I look at what my friends think about me, the same. So most likely, all these things are only in my mind. And at that time, I didn't work, so I was alone at home, and I had a lot of time to spend creating these negative thoughts. So that it was this will happen like when I go to sleep in one night, I felt like this, and then all the day, all the next day, I felt like this, and then at the end of the day, I realized all of these are in my mind, and this is the, let's say, the only thing I can control is the thoughts that are in my mind. And I said, okay, put them away, ignore them, and just realize that this is just a period in time that it will, if you get past it, it will all be well. And you need to. I remember there is a Steve Jobs. I'm not, let's say, a fan of Steve Jobs, but he did a speech at a university when they graduated, and he discussed about three, I don't know, three pillars, three events in his life that changed him and made it what he was. And the idea was that he said at some point that he was fired from Apple. He brought a Coca-Cola CEO, and they had a problem, and he was fired, and from his own company actually. And then it was very very interesting that he was in this time he bought Pixar, and Pixar actually became a very famous anime company and 3D render.
He bought stock in Pixar, right? He bought some of the
I think he
stocks
bought
up,
actually a
and
lot of
then
stocks. I think he actually had the decision power in Pixar, from what I read.
uh huh. She had like he had maybe a board
Yeah, yeah,
seat or
and
something like that.
maybe, but a big boss is from what I understand. That's big decision. And actually, he came back to Apple. He built like I think Next computer or something like that is called. So he built like a microcomputer, and actually Apple bought that company, and from that company, Macintosh arrived. So from the actually he came back through the, let's say, the back door, and also said
Yeah.
that he dropped. And actually, she said that it was very good that they fired him because it came back better. And the idea was that he dropped, I don't know, Harvard or some university, and he said that he decided to stay that year there, and he had the liberty to go to whatever course he likes. And he decided to go in a calligraphy course, and he said that because of that, when they created the the fonts on the Macintosh, he was insisting to create them very beautifully, and he said we have the most beautiful fonts, and he said like, and because he said like, and because Microsoft stole it from us, now everybody has a beautiful fonts. And actually he said that he can own all this to that course. So he said that at that point, if I looked at now in back in time, I see the dots connecting, everything makes sense. But if you look if you look back then, you don't see the dots connecting. You just see a fuzzy future. And this is what I realize if I look now back, because I think picking Rust and getting past those problems, I think it was the best decision of my life, actually, on all plans, because this helped me professionally, helped me become more independent, give me freedom, actually made me more involved in all these communities, everything. So it actually changed my life. I can say that it changed my life. And uh, if I had someone back then, not necessarily to teach me Rust or something like that, but just like a friend, and tell me, just, I don't know, just accept that the dots will eventually connect.
Yeah.
You don't see now, but they will eventually connect. So if I would have someone back then, he would have helped me. So somehow now what I'm trying to do is these courses is be the mentor that I didn't have. This is actually what I'm trying to get. Of course, I want to be an active mentor. I don't want to just say, okay, it will be fine. I just want to offer you also some insurance and offer you some ways to get past through that. So that's why I want to do a Rust course. And initially, I was thinking to do it because how I've seen those students that I told you that they came and they didn't know Rust, but okay, they somehow managed to do it. And the idea is that I want to help them. I want to help the community that I built around this project. And I said, okay, why keep to the community? Why not make it public? And then I put on LinkedIn and on everything. And actually now I think there are almost 30 people. Uh, they joined the course, and most of all are not from this project, from this community, which is great. And they are all over the place, and they distributed all over the world. And then I realized that okay, I can do Rust, I can do cryptography, I can do algorithms and data structure because this I like. Okay, I can do more. Some I will, for example, I want to learn eBPF from the kernel module, and I want to do learn also kernel development. So I will learn this as while, and while learning, I will teach a course from this, and it will help me also. And I thought that okay, maybe other people from the community will want, and I asked around, and actually it became like a, I don't know, a movement, and people started to participate, and we actually started a DevOps course. We will start a QA course. We will have the Rust course, and then we'll have a UI UX course. So actually, we have a list of many courses that we want to do, and the idea is that I'm a advocate of. So I like a lot the free open source software, and the same I see for education, or at least for information. So I'm a very pro addict of, no, not addict, advocate of, I know how it's called,
Freedom of
yeah,
information.
yeah, but like FOSE, like FOSI, like free open source education.
Ah, it's like FOSS, like free open source software, but free open source
Education.
education. Yeah,
So the idea is
that's cool.
that I consider that access to, I mean, yeah, access to information should be like you have access to air, wind, and sun. So these,
A human right,
yeah,
basically,
human, it should
almost.
be in human rights. Yeah.
Human right, yeah.
And even if you I don't know, write a book or something, because I had also an offer to write a book, and somehow decided to accept it. It's an Rust advanced writing performant advanced Rust application or something like that, and it's a combination between Rust advanced concurrency performance for network application and of course cryptography. I included cryptography, and it's a, let's say, a big book. It should be finished by September this year, and the problem is that, so I decided to write it because of the fact that that they give me some percentage, but I actually didn't enroll for the money. Uh, I decided to do it because there is this concept of if you teach or if you write about something, you have to do these models in your brain that it helps you to better understand this information, and you need to read about it, you need to better understand it. So actually, I want to become better at understanding better all these concepts and read a bit more about them. So actually, I do it for me. Let's say. So you can see me as a selfish guy. If I give you something free, let's say also the courses, I give you something free for satisfying my selfishness. So
Yeah.
the idea is,
Well, hopefully some good content comes out of it.
oh
And
yeah,
if let's say I'm a listener, I want to learn Rust, and I'm like, wow, Rust course like this sounds awesome. Like, how can I get involved, and how can I actually take this course?
yeah. So we have like you could share. I think I sent it, but you can
Yeah, we'll share the
the
links
links.
and
So
yeah,
actually, we you created a Discord group. So I'm very fan of Slack for work projects, and I like it because it's very practical. But I've noticed that Discord is way more popular especially between, I don't know, teenagers and gamers. Actually, this is how Discord arises from the gamer.
yeah. The user base is insane. There's billions of
Yeah,
users
yeah,
now, I
yeah.
think.
And the idea is that it's way easier to, I don't know, have people join the Discord one because most likely they have a Discord application already, are familiar. So also the the Rust community is in Discord. So I mean the official, the Rust Foundation one is in,
Yeah, and then there's all the unofficials like
yeah, the official.
the IRC one. There's one on not Freenode but Libra chat. There's one. There's a bit here and there, but yeah, the Rust Foundation, like you said, and there's like three different Rust groups on Discord, even more. I bet there's like
Yeah,
1,000
three main.
different small
Yeah, yeah,
ones,
yeah.
probably.
Yeah, three main ones. Yeah. And one, let's say, I don't know, if I were to convince you to come join the course, is
Yeah,
we will follow the Rust book. So I don't want to reinvent
the
like
wheel.
like that. I want to add, okay, some of the nice particularities. Like for example, like I told you with that RAI model, I want to add some particular things that I think are good to have, and also we'll add some more examples. So the Rust book, I think it's a very good learning resource, and it has also some exercises. Let's say at, I don't know, 3 mini projects you build or something like that, and is the CLI parser, is the mini regex, and the web server from what I remember, and the idea is that what I want to do, I've seen other doing, and I think is very practical. So I want to have a project that takes building it takes the whole duration of the course, and based on what we learn at the course, we can build parts of the project. So let's say we build a CLI application, then we learn about, I don't know, strings, stir, and something like that. We learn to read from the console, from the citadine, and we learn to do this. Then I don't know, we implement stuff and stuff, and then at some point we learn something more. For example, we could talk about clap, for example, and then we use clap to parse the arguments. You see how easier it is. Then if you make, I don't know, a web server, first we do it single threaded, then we add Tokyo with concurrency and multi-threaded,
Nice.
then we add,
Make it more and more
yeah, and
advanced.
then we add, for example, we add exception handling. Then okay, now
Nice.
we just close the client and the connection gets dropped. And okay, here we have an exception. Okay, we just print it and do anything. But after that, we catch this exception result and we do something with it and stuff like that. And I want in the end of the course to have a fully functional project, and for you also to see how a project is built from scratch. And the idea is that I don't yet have the project in mind. So I have some, but I don't have the perfect one that could fit all. Most likely, I want to do something that involves networking and concurrency. I thought of a chat client is very good to do, but they're very, again. not yet another chat client because are
Yeah,
way too many.
there's a lot out
There's a
there.
lot of that. So I could do something with encryption, but maybe it's a bit too complicated for starter, because it's cryptography too. So I don't know. I see. Maybe I don't know. Maybe I'll do a poll and ask people around. But maybe I don't know. Key manager. Maybe it's reasonable to do, and like a key manager sync with another device to have also some networking. We'll see. So for sure, I'm sure I will come with a good idea. Mostly, most of the times I do. Also, I think with this encrypted file system, it was a very good idea to do.
Yeah, it was
And
definitely.
hopefully, I hope that all this will be useful for the participants. And because I want to make it so all will be free. It will be like I don't know, 2 or 3 chapters, depending on the chapters. You'll read over the week. You can ask questions over the Discord, no problem. We can have short talks, the same, but we'll have like a main 2 hour call once a week where we can discuss your questions. We can discuss like assignments that you have for last week, like what's for the next week, and so on. And all this will be. Actually, I thought a little bit what because I see there are, I know, Coursera, Udemy, another a lot of platforms to use, and I was thinking what platform should I use to help me, and I something strike me, and I realized that at least for the Rust course, if you look at it, is very similar to a project. So if you look at it, the documentation is like the requirements and the specification. You can keep this in wiki, for example. Or okay, in
Yeah,
our case, it's a public URL. You can keep it there. But let's say for other documentation, you can keep it in wiki. Then each course individually, it's let's say like a session where we stay and we discuss about the parts of the requirements, we take parts of the requirements and discuss architecture and how would we implement it. That actually this is what we do. You can create a GitHub issue, you can take some chapters from the book, we can discuss it, comment it, so on, and then we start to implement. Then we create another issue to implement it. You have code, you link it to the issue, you get a pull request, I review the pull request, everything is there documented, and then all this is organized with GitHub projects. I can use GitHub project for statuses and so on. And actually, it fits very well this model. So and you have
that's
all
nice.
this for free. So
It ties great into like the
exactly, really.
open source ethos of it, that someone can just like check it out and they can fork it and they can use
Exactly,
it and they can like
exactly,
they can get value from
exactly.
it,
So this
which I think is
this,
awesome.
this
Yeah.
is the next step. So after we have all this, so we actually create like a structure, like a logistic that you can actually use this repo, fork it, and create your own courses. You can hold your own courses. Okay, ideally if you sell it or something, I don't know, add something in addition, because okay,
Yeah,
don't
yeah.
just take my word. And
Put
but I cannot. This is like
commercialize it.
this is how
Yeah.
open source is. I cannot force you to do. Okay, if you still do it, maybe donate me something, because what I do with the money, I donate back to the other communities, because this is what I do. And yeah, I want to have all this open source, and where it fits, we'll use this repo as a template, and we'll have this working. And another because somehow I see them related. Another so all this I do also for the community. Okay, I do it also to help me. I do for the community. I don't do it for, I don't know, training people to come work in my project, because I cannot offer you money. Because yeah, with two of my projects, I'm trying to get some funding, but it's not sure. It's hard. And but if I do, everyone will be reimbursed, because I it's easy on GitHub. I see everything what everybody does, and what's, I don't know, QA and design stuff, which is not directly related. I actually have a document with everybody what it did, so I won't forget anyone. And I'm that kind of guy that all the money will be split as it should be. So it will not be like so if we get like, I don't know, consistent funding, you can decide we'll have like a company. We could give you like something like shares in the company. We could give you like a salary. We could give you a combination. It doesn't matter. All this
Yeah.
will
They're all
yeah,
sideline
these are,
ones.
let's say,
Yeah.
the not the interesting part. And the nice part is all these people are. staying and they are contributing for, I don't know, learning experience. They like to build nice products. They like the interaction. They like the community. They like
Yeah.
all this. And also to help and keep them motivated, I'm organizing a weekly coding challenge where we give various tasks. For example, this week is to build a search engine library. So it's something similar to Elasticsearch. It should support something like prefix query, suffix query, contains wildcards like asterisk and question mark, and it should handle like millions of, data sets of millions of words. So you should, I don't know, fetch, for example, because I put some data set links. So you could fetch the whole Wikipedia, for example. There's a
Hmm.
site where they have like 70,000 books. So you could fetch all those books. And okay, based on your implementation, you could use all that. You could use few books and so on. And the idea is that I want us to learn the basic. I'm familiar with many because I work with Elasticsearch and I had to implement some quite interesting queries. And I read a lot to see how they are doing it and how to use it, and I understand what is happening behind the scenes. And this is the idea. That I want to help them, and of course, I give them some hints. So, for example, it's very good to use a tree structure. For example, it gives you the ability to do prefix queries and in log n time. And you should also use, for example, for contains for suffix. It's actually a prefix query. I mean, you reverse the text and you do a prefix on it. So it's
Yeah.
suffix. And then
Uh,
for
yeah, but I bet it's more like rewriting it in Rust is a lot more memory efficient
yeah,
than Elasticsearch because Elasticsearch is like known for just eating memory.
yeah, I think, and on the Elasticsearch, I think the memory eating part is the, so not the Lucene. The Lucene, maybe it's a bit more. It's in Java too, but maybe it's a bit more efficient. Lucene is the search engine, let's say, and because it's an interesting. I don't know how do we stay with the time? It's a free. I mean, it's a free discussion, or you want to summarize it, or how? Because
I think we'll
go ahead.
I think we'll try like to end it now on a note, and then I'll just edit it down to a shorter segment. I
Okay.
think, but I think it will be like now we've done like 2 hours, so I think like it will be edited down to like an hour and a half, an hour and 20
Okay.
minutes, and then
Because
release it.
I just wanted to, I wanted to say these two uh, for related to Elasticsearch. So when I learned Elasticsearch, I read the story. By the way, do you know how Rust appeared? This is
No,
also a nice story. I'll tell it after. The idea with Elasticsearch is that this guy, Shadon, I know what it's called. He was okay married, and he was working in distributed systems, and he was his wife told him, okay, you work in IT, can't you make me a recipe website where I can add my recipes and then search for the recipe and print me out and see what to cook today.
yeah,
Okay, he started the project, and okay, he looked what there is out there, and he found the Lucene, which is very great. And but the Lucene is standalone library, so it's not distributed. And he thought, okay, I work in distributed systems, let me do a distributed over it. And he started to do a distributed operation over it. And of course, he used his skills. He did it in he exposed a REST API, and he added like types over it because added queries with JSON, and make it, let's say, developer friendly in a distributed way. And actually, he he kept on working on this project, and then he gave up his job and continued working on this one. And okay, you see what they are now. So they exploded, and still the recipe website is not finished.
uh huh,
Like I thought it's an interesting story. And the the Rust was how it appeared. So this guy, I'm very bad with names, so I don't remember his name. Sorry, and but it's a public information. You can quickly.
yeah. You can look it up.
Yeah, and the
Yeah,
idea is that he in one day he went home and the elevator was broken and he stayed like 27th floor, and it was not the first time it happened. So he was very disappointed, and he said, okay, uh, how lousy of developers are we and the technology is that we cannot write a bloody easy C program to manage a bloody elevator functions. So he was like disappointed. Okay, like let's say normal reaction, a normal guy will go home, swear a little bit, open a glass of wine, drink, look at a movie, and move on. And
Yeah.
instead, what he did, he's a C. He was a C developer back then at Mozilla. He decided to write a language, a programming language to to solve the C problems that okay he knew about because he was a good C developer. Then he it was like a toy project, and then he showed it to the Mozilla team, and then they incubated in Mozilla. Then Mozilla decided to make it open source and give it to the Rust Foundation, and this is how Rust became a popular.
Wasn't it like involved in like the Servo project from Mozilla, which was like an effort to rewrite Firefox to be memory safe?
I don't know
I
that,
think it
but
was
it will make a lot of
maybe.
sense.
Yeah, that's what I heard. Yeah, I think we're getting in on time now. So, do you have any closing words for our listeners out there, or do you have any advice for new people that they want to play around with Rust? Where should they start?
I think definitely you should start with the Rust book, which is a very good resource. But I don't know, after few chapters, let's say, try to find a personal project that you like. Just think of a problem that you have, just like that. Think of a problem that you have. Doesn't need to be. You don't need to think it big, like I need to solve a problem that many people have. No, just think of a specific problem that you would like the software for it. It doesn't matter that it exists because it will be a learning experience for it. Like the challenge you have. Of course, you have Elasticsearch, but the idea is to learn about it and just building it. And at the end of the book, you'll have, like I said, you have working project first, and it doesn't matter if it's a I don't know, practical or something. You can put it on your resume. Actually, my previous job, the employer found my found ranks on GitHub, and he had to
Ah,
collaborate, and he actually hired me with a very high salary without any interview, because he said, I look at your commits, and it's enough for me. And yeah, it's this is great, you know.
that is awesome.
Yeah,
It can lead to so many more opportunities and maybe some new job opportunities or just collaborating or just learning
yeah,
is
yeah, just
amazing
use
in
as a
all the
learning, and
project.
that's why I wanted to. I didn't have time to finish then, but that guy who said that don't build your own crypto, and like it was shutting my mouth, you know. And what I told to him is like, okay, I first of all I didn't build my own crypto, so you are wrong. But second of all, even if I would, I specific, even if you look now in the readme of the project, it states that it's in active development and is not intended to be used in production. And it's mostly for educational experimental purposes. And the idea is that this is what I would do for a cipher. So actually, I will do a repo where I will play around with cryptography, and it should be used for cryptography enthusiasts who want to join in the cryptography. And I said to that guy, okay, if we leave only the experts to handle cryptography, those experts get old. At some point, they die. What happens after
Yeah,
that? Who handles our
they're dying in pieces.
like, who handles our cryptography? Because you will be ending up with a lot of libraries and a lot of machines to work, and nobody will be around to fix your bug in I don't know, HTTP 3 or TLS 1.4
Yeah,
or something. Or there will be no, there will be nobody around to fix a bug in 1.3 and create 1.4 for you, because this
yeah.
is what's happened.
The,
This is what happened with the. So I'm sure you are familiar. Before TLS, it was SSL, and it was, I don't know, like 5 version of SSL, and there are.
yeah, and then you had TLS 1.1, which was got deprecated, and then you have 1.2, which is like still stable, but then you had 1.3,
Yeah,
which was like it. I remember when 1.3 got released, and everyone was like, "Wow, this is awesome!" And then like a while later, everyone is like, "Just disable it, and like just put it in a box and forget about it and never talk about it,"
yeah,
because it's not ideal. so to say.
Yeah, and the idea is that all these new versions, most of them also have some, let's say, performance and stuff like that, and let's say uh, optimizations and stuff like that. But most of them they appeared because they were fixing an issue that they found. Okay, it was
Yeah, they're use case
yeah,
specific. A lot of
it was
these.
it was
Yeah.
not always found, let's say, by an attacker in the wild. Most of the times, actually, it was found by researchers working on the project, on the protocol. But it's something that an attacker could have been found. So
Hmm.
actually, all of these evolved because we are human and we cannot do something perfect from start. And just to just to conclude with the people that we want to get into cryptography, just I don't know, ignore like people that try to get you down because they don't realize and they forget they were like you some at some point.
Yeah.
And about Rust, no matter how I know difficult it is, just think as one example in your life that it was difficult and you didn't stay there and just die. You just I know rise, fought, and you crossed the one. And this is what makes you more resilient in the end. And this is you need to do this. This is life. Fail again, but fail better. This and
Yeah. Keep pushing.
just imagine that the dots will eventually connect.
That's, I think that we're going out on. That's a very good advice, and we will have all the links in the show notes and in the blog articles. So definitely check it out and check out the courses. And thank you for tuning in today and listening.
Thank you also.